All right, what we're going to be doing is today we're going to be working on graphing functions. Last chapter we learned how to multiply to get an x squared, and then we learned how to factor. Today what we're going to start doing is actually graphing. It should say a equals f of x equals a x squared. I couldn't get the little 2 up there, so I had to type it with the caret. Okay, so first of all, we have to just learn what a quadratic function is. A quadratic function is a curved function that has the standard form of y equals ax squared plus bx plus c. The quadratic function has a u shape, and it's called a parabola. What we're focusing on today is just this. We're not going to have this for a couple days. We're focusing just on the ax squared, but we probably shouldn't white it out. But that's our focus today. This is what a quadratic function looks like. This one right here, this is the parent function. So all quadratics are based off the parent function of y equals x squared. That's what this function is. There are some pieces that we have to identify above this, about this. The first thing is this point here. This is the turning point. This point is called the vertex. These other points are found, so if I make a table, and this is how we're going to have to graph them for a while, I always am going to start at 0 for right now, and it's y equals x squared. So if I plug in a 0 squared, I end up getting 0. So that's where this ordered pair is. And whenever you find the vertex, you're always going to plug in 2 points to the left, 2 points to the right. So I'm going to plug in a -2, and so I get -2 squared, and a -2 times a -2 is a +4. So that's where this point comes from. And then I plug in a -1, and so that's -1 squared. -1 times -1 is +1, so that's where this point on the left comes from. And then the ones on the right, I always do the reflection, so I plug in a 1. 1 squared is 1. So that's where this comes from. Oh, don't forget the squared. And then I plug in a 2, and 2 squared is 4. If you notice, it's the same points on both sides of the vertex. That's because it's called a line of symmetry. This dotted line is the line of symmetry. And what we call it, not just line of symmetry, we call it the axis of symmetry. And the axis of symmetry always goes through the vertex. And if you notice, it's a vertical line. And so vertical lines always have an x equals. And so you find out where it passes through. And the x value that it passes through is at 0. So my axis of symmetry for this is x equals 0. There are other parts of the graph that we're going to talk about, but the main two things today for being able to graph, we're going to talk about the vertex and the axis of symmetry. All right, so we've been doing domain and range all year, and we're not going to quit. You have to keep knowing it. Remember, domain is your x values. Now, it does not really look like it, but this graph is going to keep going up and up and up, and it's going to keep going to the right all the way. It's never going to stop. So even though it looks like it gets thinner, it will eventually cover all the points on the right, and it will cover all the points on the left. So this domain is all reals. It has infinite solutions for the domain. They all exist. The range, however, if you notice, it doesn't have arrows on this, but usually parabolas will have arrows at the end. This is going up. And so it's only these positive numbers. So range is the y values. And so this one's going up, so it's greater than, and it actually touches this vertex, so it's greater than or equal to. And then what we do is we just find out how high does it start going up from. And it starts at 0. So the range for this one is it goes up from 0. All right, so the next thing we have is when is a function increasing? Well, we kind of think about it like we would read a book. If I were on let's say a sled or something, and I start on the left, I would go down right here. That is actually where it's decreasing because it's going down, because you always read it left to right. So the function is decreasing on the left of this vertex. So whenever x is less than or equal to 0, probably not equal to, just less than 0, it is decreasing. And then we notice after I get here, because I'm going to go from where I stopped at the vertex, and now I keep going, and now it's going up. So that's where it's increasing. So it increases when x is greater than 0. At 0, it's hanging out down there. It's not doing either. So that's why I don't include the equal signs. Okay, so again, when you find increasing or decreasing, you start on the left side and figure out what's happening on the left and then what's happening on the right of the vertex. All right, so now let's try and actually do some of these. I'll guide you through the first one, and then I'll give you an opportunity to try the next one. So the first thing, whoa, we zoomed in. Hold on. Okay, so the first thing we need to do is we need to find the vertex. Well, this is our vertex. And the ordered pair for our vertex is 3, 0. Now we need to find our axis of symmetry. Now our axis of symmetry is the line it folds on, and it might be a good habit for you to write that dotted line for a little bit. And that will also help you remember, oh, that's a line, so it has to be an equation. And where does that line cross through on the x-axis? That's right, it crosses through 3. Okay, so now we need our domain, and I just write D for domain. And our domain, it's going to the left. It doesn't have arrows, but it should have arrows. I don't know why I don't put them on the assignment. So it goes to the left. That's an ugly arrow. And it goes to the right. So that means our domain is all reals. Our range, however, it's only going up. And range is a y value. So since it's only going up, we're going to see it's greater than, and it's greater than this y value right here, which is the vertex of the y, which is 0. All right, last thing, we're going to have to, let's see if we can squeeze this in. So increasing. So again, let's just take our start on the left. That's right, increasing and decreasing. There we go. So let's start on the left. And on the left, look, it goes down. So that's where it's decreasing. It's going down there. And so it's decreasing everything to the left of the vertex. So it's decreasing when x is less than our x value at the vertex, which is 3. And so now let's look here. We keep going now, and now I go up. For my vertex, it ends up going up. So that's where it's increasing. So it's increasing when x is greater than 3. Okay. All right, I'd like you to take a second to try number 2. Once you think you have it, go ahead and press play. Okay, so you should have had your vertex right here, which is at 0, 3. And then my axis of symmetry is that folding line. And so that is x equals 0, because it crosses through the x coordinate of the vertex at 0. Then our domain, it still has arrows to the left and to the right, so that means it's still all reals. And then our range, we haven't had a range like this. This one's not pointing up, it's pointing down. So hopefully you recognize that it was less than or equal to, and it's less than or equal to its highest point, which is the y value on the vertex, which is 3. And now we need to do our increasing and our decreasing. Okay, so increase. So I start on the left always, and look, this time I'm going up. So this one is increasing when x is less than 0. And then now I follow, oops. And so now I keep going with for my vertex, and I go down. That's where it's decreasing. So it's decreasing when x is greater than 0. So you have to think about what it's doing to the left of the vertex and what it's doing to the right of the vertex, and that will help you with increasing and decreasing. Okay, so those are the key functions and looks of the graph. Now we need to find out, what does an a value do? Okay, so there's two things that the a value does. If it's a positive a value, the parabola is going to go up. It's going to be a happy parabola. If it's a negative a value, the parabola is going to go down. If the absolute value of a is greater than 1, it's going to get skinny, which is actually called a stretch. It's going to get thinner. So we stretch it tall. So you can kind of think of how you would stretch a rubber band and you stretch it tall, and so that's why it gets skinny. When it's less than 1, this is actually when it gets wider, which is called a shrink. And this is confusing, I know, because skinny and shrink kind of seem like they go together. But what happens is this one, you actually get wider. You're shrinking the height of it, and so you're kind of compressing it down. Okay. Now, the reason we only look at the absolute value of it is because the positive and a negative just affect the direction of it. They don't affect the kind of what usually we used to call the slope of it, but we wouldn't call it the slope for this. Okay, so let me highlight the words that you want to use. You want to use the word stretch and shrink. All right, and so what we're going to do is we're going to try a couple of these, and how we try them is we're going to have to make a table and plug it in. Okay, so we have to describe it, and then we have to graph it. So you see this number in front. It's a positive 2, so that means we know it's going to go up, and that value 2 is greater than 1, so it's going to be a stretch. All right, so we're only changing one thing, and so we're going to always start, because there's no pluses or minuses or anything, we always know that the vertex is going to be 0, 0. But let's plug it into C. So I plug in a 0. So 2 times 0 squared. Well, 0 squared is 0 times 2 is 0. It's going to be tight fit, so I put my point here. And then I pick 2 numbers to the left and 2 numbers to the right. So negative 1. So 2 times negative 1 squared. Well, negative 1 squared is a positive 1 times 2 is 2. So I'm going to go to the left 1, up 2. And then negative 2. And so 2 times negative 2 squared. Well, negative 2 squared is a positive 4 times 2 is 8. So I got to go all the way up here. All right. Now let's go to the positive side. 1. 2 times 1 squared. Well, 1 squared is 1 times 2 is 2. And then I plug in 2. 2 squared is 4 times 2 is 8. Now, some of you might recognize that, oh, look, I know it's a parabola, so I have to have an axis of symmetry. So when we do the next one, we're going to do reflections of it, and I'll show you what that looks like. But now I just kind of make my U shape the best that I can and throw my arrows on it. Right over here, we're going to start with this vertex, and I'm going to show you this one, how you could do it by using an axis of symmetry. because I know it's going to go through the vertex. And again, the reason I know the vertex is at 0, 0 is because I'm not adding or subtracting anything. And so that always tells me my vertex is at 0, 0. Okay, so I'm going to plug in. I'm not going to do the negatives. I'm going to do the positives this time. Because I'm so far away. Okay. So negative 1/3 x squared. So negative 1/3 times 1 squared. Well, 1 squared is 1. Times negative 1/3 is negative 1/3. So I'm going to go over 1 and I'm going to go down 1/3 right here. Now, I know it's a reflection on the axis of symmetry, so I'm going to do the same thing on the left. I'm going to go to the left one and down 1/3. There we go. That was pretty close. All right, and then now you could do 2, but I already know 2 is not divisible by 3. So when you have something that's dividing, I always try and do a multiple of that number. So instead of doing 2, I'm going to do 3. Because it may not work, but it's going to be a little better than a 2. So I'm going to do negative 1/3 times 3 squared. 3 squared is 9. And then 1 times 9 is 9. Divided by 3 is 3. And so I have to keep that negative there, though. So now I'm going to go to the right 3 and down 3. And I'm going to do the reflection on the same side. To the left 3 and down 3. And now you can see it's a wider graph. But again, when you have a fraction, I would always plug in something that's a multiple of what you're dividing by. So I could have done 3. I probably could have done a 6. I could have done a 9. But you want to do a multiple of what in the end you're going to divide by. All right, what I'd like you guys to do is I would like you to try 5 and 6, and then we'll come back and check. Okay, so for 5, you should have started with your vertex at 0, 0. And I have 1/2 x squared. So I'm going to plug in a 1. And I plugged in a 1, but really, if I think about it, I could do that rule that I just said, that instead of plugging in 1, plug in a 2. Because 2 is divided by 2. 2 is divisible by 2. And so now 2 squared is 4. Divided by 2 is 2. So I'm going to go 2, 2. Now I'm not going to pick a 3 because it's not divisible by 2. So I'm going to pick a 4. So 1/2 4 squared. So 4 squared is 16. And 16 divided by 2 is 8. So I'm going to go to 4 and then all the way up to 8. And then remember my axis of symmetry. I'm going to do the reflections on the other side. So this one is at this height of 2, and it's to the left 2, like this one was to the right 2. This one's had a height of 8. I went to the right 4 here, so I'm going to go to the left 4 here. And there's my graph. Oops, I missed a dot, but you get the idea. Oh, you know what we forgot to do? We forgot to say what kind of transformation this one was up here. This is a fraction that's less than 1, so this is a shrink. Same thing here. This one's a fraction that's less than 1. This is a shrink. For number 6, this should go down because it's negative, and 3 is bigger than 1, so this is a stretch. All right, so now we're going to pick our numbers. So x and then negative 3x squared. I know it's at 0, 0, and so I plug in a 1 first. So 1 squared is 1, and 1 times negative 3 is negative 3. So I'm going to go to the right one, down negative 3. And remember, you could do your axis of symmetry. So I know this is on the other side. And then I'm going to do a 2. Negative 3 times 2 squared. 2 squared is 4. Times 3 is negative 12. All right, it's off the grid, but I could still kind of guess that it's right here. And then I do the reflection here. So you can see that this one got, whoa, look at that line. This one got super skinny. And so it stretched the graph tall. And that's it. So there's a lot of information to know about parabolas. We just started with the A values graphing, but you do need to be able to find the vertex, axis of symmetry, domain range, and when it's increasing and decreasing.